Let's start. This has kind of turned into a whole deal, but I just as soon keep it fairly informal. I think we have a better chance of people grasping stuff if you feel the freedom to stop me and ask a question or correct me. I'm by no means coming at this as an expert of control wiring. I'll teach you what I know and we'll go from there. Let's go over a quick syllabus for this next hour. I'll go over a little bit of what a circuit is, what a control circuit is, some of the pieces that make up a control circuit, and then we'll take like a sample problem and work out how we build it. Then I want to hand out a sheet and have you guys build that same circuit. If you can't do it with a pencil, you can't do it with wires. It's a lot harder to do when you're just looking at pieces, trying to remember what's doing what and connecting wires. It's much easier to follow that wire just like the flow of electricity that it's doing. You're drawing it in, you're getting your circuit all the way to what you're trying to control. So we want to do it on paper. Once your system works on paper, then we'll, I only got enough for 4, so that's why we're split into 4 tables like this. If I had known we're gonna have this many people, I would have tried to get more stuff. But we'll split into 4 groups and actually build the control circuit that we just drew. And depending on how fast that goes and how easy this is, some tables might get this easier than others. We can just keep going with it, make more complex problems, and eventually we'll get to where we've stumped you. So since we have guys here that aren't electricians, let's go super basic at first and just say as simple of a circuit as you could have, running power out to a light. We throw a switch in that so that we can turn the light off and on. And with this circuit, we'll say this is a 120 volt circuit. So this is just a switch we're controlling by hand. Everybody understands how this works. If we were to say that rather than a light, this is a motor, and let's even make it a 3-phase motor. So now, to control this circuit, we've got a disconnect down there that we can turn on and off the entire motor at once. If you've got a plant, manufacturing facility, something like that, you're spread all over paint tanks and conveyor belts and things like that, it's pretty impractical to send a guy all over the place in the morning turning every motor on. You can't supervise the motors by just manually turning them off and on. You could say, if you've got a control booth way over here, and over here is where you want to actually turn it off and on, you could run this wire all the way to there, get rid of that, and now make your connection here. But if this is a big motor, you're drawing a lot of amps, this is a big wire. If your control booth is 400 feet away from some of these motors, this is extremely expensive, plus the fact that this is a huge control panel now. If you're actually physically throwing on these motors, having the voltage need to run through it. So what we do, this is why there is control wiring, is to say even though there's a lot of amps going through here, am I blocking everything from you guys? Even though there's a lot of amps controlling this motor, let's say this is a 480 volt motor. That's going to be confusing if I write it like that. And okay, big powerful motor down here. It doesn't take a whole lot of power to close this switch though. So we can actually throw in a contactor here that does this job. This is a lot of work, this is a lot of power. This is no big deal. We can even run this guy at 24 volt. So now we can run little wire, safe wire, and we can bundle a lot of that together so that all the way back in our control booth, we're turning on and off all kinds of motors pumps, lights that are telling us what's running, which direction it's running. So it makes it practical to do it if you can do it in low voltage. This here is a power circuit. This is a control circuit. So the fact that we're doing that, that's control wiring. I should probably jump from there into some of the basics of control wiring. Let me see if I'm off script. Yeah, no, I think we're okay. Control wiring is really switches and relays. And relays are switches. So it's all switches. It's just controlling when things are coming on and off. Part of control wiring is monitoring it. So lights and things that are telling you what's happening out there. But the control of it is all switches. So there's a simple push button switch. Another simple push button switch. This is normally open. This is normally closed. That's how we refer to these, because if power's coming along here, you don't have a complete circuit until you push down on this button. This is normally open. And the normal condition of anything when it's talked about normally open, normally closed, if you're holding it in your hand, you just pull it out of the box. That's its normal state. No power is on it. This switch is open. This switch is closed. So power is always running through this switch until you push down on it, then you're breaking a circuit. So this is normally open, normally closed. A few other kinds of switches, just because you'll all, whether you've seen them already, I know the mechanical guys deal with this. As you're troubleshooting stuff, you'll see all kinds of symbols that are like a pressure switch. Some form of that. This is, they a little bit show you what they're doing, just kind of like these guys. You can kind of see looking at it what it's trying to tell you. This is saying when pressure pushes, actually I shouldn't draw it like that. Let's do it like that. Okay, with pressure on this, it's going to break that circuit. This is a normally closed high pressure switch. When pressure gets too high there, it's going to break that circuit. This guy here, I didn't really touch him. That's a thermostatic switch, and you can kind of see that when metal heats up, it expands, it's going to push that up. So that's kind of what they're showing you there. When this heats up, it's going to break that circuit. This is a normally closed, open on a rise in temperature thermostatic switch. Every schematic draws it a little different to a degree. They try to keep them the same, but if you know what you're looking for, you can usually tell what they're trying to tell you. And the way they position these things is also part of that. Whether they're telling you it's open and it's going to close with this action, or it's open up here, it's going to close by coming down. So all of those different pieces are telling you part of what the switch is doing. A relay is really a let's do this. So this switch is going to close, but we're going to use electricity to close it. So an electromagnet, just to say real briefly, if anybody doesn't know how that works, there's a magnetic field around any flow of current. Any wire, that's how we use our low voltics. We're picking up that magnetic field. The magnetic field is traveling with the flow of electrons like that. When you run the coil, you're increasing that magnetic field, and then you throw a piece of iron down the center of it, and you've increased it even more. So now when we send power across these two terminals, we've created an instant magnet. You take power off, the magnet's gone, turn power on, you've got a magnet. So with this contactor, with this relay, we could send 24 volts across these two. When that happens, it's going to suck this down and close this. So we can, way over here, we can send 24 volts to this and affect this circuit. That's how contactors and relays work. There's there's very little difference between a contactor and a relay. Think of it like a contactor is a diesel truck and a relay is a Prius. Both of them are going to get you there. The diesel truck can do it with a load. So a contactor is this same idea for a contactor would look more like this. Your power's coming in and out there, and it's slamming this thing down, and this, they're all rated different. You get it based on what you're running, but this is capable of taking real amperage through it, where a relay is really for logic. It's just for control wiring. You also can have this turns it from a single throw to a double throw. Now on both directions of this function, it's doing something. So there's a spring. I didn't draw this real great for a spring here, but I guess typically there's a spring like that. Here's a pivot point. This sucks it down, magnet goes off, the spring pulls this side down, pulls this back open. So you could send stuff off both wires. Here's your common. This relay is switching you between these two tracks. So this guy is your normally open. That's not much different than an O. That's normally closed. So if you're trying to break power when the relay goes, you'd be on normally closed. If you're trying to send power through it, when you send power to your relay, you'd be on normally open. You can also we can do off and on with a bunch of circuits. So now this relay is a 3-pole double throw. Okay, I'm worried some people are glossing over, so let's start turning this into something a little more practical. I don't want to give you too much information that doesn't make any sense, but I also don't want to just blow past everything and not give anybody the fundamentals. All right, so we want to, let's start with all of this being the same voltage. So we've got a light down here. I won't even write the voltage, this is all the same voltage. We've got our off, our on. Right now, if we send our one wire down, looks like all we have to do is push this down, our light's going to come on. But these are momentary contact switches. We take your finger off it, the light's back off. You can get the light on just as long as you're holding there. So for this to work, we need to also throw in a contactor. I'll just do that for the contactor. And then I'm going to draw the normally open like that. It's a little easier for wiring diagrams to draw it like that. Normally closed is just like that. Okay, so with just a single pole contactor, we can now say when we, this is not accurate. Okay, when we send power through to this coil, we push this button, we're trying to send power to the light. Okay, so now when we push this button down, we are sending power to the light. You can follow your path, goes through this. This is always closed until you push it. We push that down, it's going to go through there. This is a direct line all the way to the light. The light's going to come on and this coil is going to come on. But at this point, you take your finger off, it's still all going back off. When this coil goes down, it's going to close this. It's going to take that normally open contacts and close them. So what we want to do is say when this closes, let's backfeed this coil. So now we take power before we have this break. When this comes back off, it's broken. We'll grab power right here. So now power's coming along. Up here it just stops. It's not going through anywhere just yet. When we push this down, just like before, this coil is going to fire. As soon as that coil sucks in, that's going to close. Now this power is going to backfeed and it's going to hold that coil closed. So now the light's going to stay on up until the time this gets pushed. When that guy drops down, we've just lost our circuit because we don't have power to here anymore that's going through that to hold this on. Does that make sense? Is everybody, I may be over explaining then. Okay, so now let's take this up a notch. And we're gonna do a, you know what, let me put my pieces where I'm planning on you guys putting your pieces so that the drawing makes a little more sense later. So this is a 120 volt light now. And there's our 2 push buttons. And well, I guess on here I drew them like this, so I'll keep it like this. Okay, and we need a place to get, this is 24 volt. So we've had a level of confusion. We can't just send this power down to here. So we've got our transformer up there. I'll switch to a different color here so that maybe a little easier to follow. Okay, so let's call this hot and neutral. Coming off of this same wire, wherever you're grabbing that, we've got to get out to the light to get 120 there. 120 has to get out to that light, and we need to control it with this transformer, or with this contactor. So let's bring this guy down to there. And when this closes, when we fire this contactor, we'll complete this circuit and turn our light on. Okay, let me try another color now for 24 volt. The only thing in this that's actually using 24 volts is this coil. So just like I did with the neutral, we've got to complete that circuit. That's the unswitched side. And real often when you're sketching some of these up, I don't even take the time to draw on that other circuit or draw on that neutral. I take that as a given. I'll get a neutral there, but it's just running to all of those points. All right, so just like before, power's got to start over here. The stop button needs a chance to break everything. So we got to go through that first. If this is downstream of anything else, this doesn't have a chance to basically reset the whole system. So we're going to go into the stop. Now we're on our start button. We know, just like the picture we did before this, we're trying to get this to operate the coil. At this point, when you push that button, this guy's held down, we got power through there, push the button, the coil's going to fire, it's going to close this, the light's going to come on. But like before, as soon as you take your finger off, we're losing that light. So we still need to have this hold itself down. We can't do that with one set of contacts. If this is one voltage and that's another and you're trying to control both of them, you can't do that with one set of contacts. But with this second set, now we have a chance to backfeed this. So now we can take this guy and backfeed it. We need power here that's always there, so that when you take your finger off, you've still got power here. It has a chance to backfeed it. So we have to grab it from here, or we could grab it right there. It's the same wire. Does that make sense? Have I missed any of it? Okay. This is a wiring diagram, and it's again like the symbols. It's a little bit literal. This is how you're going to wire it, your actual components, and which wires you're running from where to where. If you're troubleshooting this same circuit, it's much easier with the ladder diagram. So I'm going to draw this same circuit before we get anything more confusing as a ladder diagram, and I'm going to follow my notes so that I don't have to erase stuff as much. Here's my ladder. Okay. This is just telling us that's what's between these two wires. And a ladder diagram is not literal in the layout of the apparatus, but it's much easier for somebody to just visually make the connection of all the conditions that it's going through. Okay, so down here we've got our transformer. This is 120 volt side, 24 volt side. We've got our light that needs to come on, and that's 120 volt. That's gonna get a neutral in L2. It's also got to go through a contactor. Okay, I'll wait to label these till we get everything else drawn up here. All right, so this is our one push button. Then we come across, we got another push button. Our coil. Okay, this is going to be, we'll call this relay 1. This is getting turned on by relay 1. So when you're looking through your ladder diagram and you're following power and you've got 120 volt across here, and you're following this along and you have 120 volt here and you put it here and you don't have 120 volt, you know that this isn't closing, you're not getting power through here, you know where to look. This is relay 1. Why is this not closed? So the ladder diagram you can take nice and literal and just follow it with your eyes. Okay, again, we've got power down to here. It's coming through here. You push the button, it's going to close that. It's going to close this. It's going to turn the light on. Take your finger off the button, it all goes away. See how much cleaner the system is in a ladder diagram? It just shows you exactly what that button's doing. It's just jumping across there so that it'll remain closed. And this is also part of relay 1. So this is that same circuit. This is a ladder diagram. The first one is a wiring diagram. All right, so there's 4 of those. So step 1 is just make the circuit on paper, and then once you're ready there, we'll pull out the goodies and actually make it work. Guys, when you start working with it, those relays are really small, and the instructions for a relay, let me hold that a second, they're on this side. They're really, really hard to see. So I zoomed in with my phone so that I could see what they're telling us. This is what they're telling us. Okay, this whole row are normally opens. This whole row are normally closed. Here's your 24 volts, and these are your commons. And they line up in a row like this. Okay, you got a common, you attach to here, you're on the normally closed, here's the normally open. You can read these numbers, because I could even read those numbers. This is what those numbers mean on the ice cube relay's base. Of out of real parts. And then when you're done, you can just, you know, these are lights, these are push buttons. This is a nice way, because I didn't know how many non-electricians would be here. This is a nice way you can just stick any one of these wires into there and bite them down. And, and here's your 24 volt. But I want you to turn one of these on when it's off. So when you first plug this in, your off light is going to come on. So you're right, that's a whole level that I didn't have you draw yet. Maybe that's the next test. I also, as they started theirs, they said, wait a minute, you gave us 2 lights. And I thought about things at different times. So clearly at some point I had planned on 2, and then somehow I switched to 1. So that's the next level of this. The lights are 120 volt, just like you're drawing. But now I want your off light, the light, whatever color you have above your red button. When we first plug this in, that should be lit up. When you turn your on light on, you're going to turn the other light on. Your first light's going off. That one's not just going to stay on all the time saying you have power. Your first light's saying it's off. That goes off. Your second light's saying it's on. This is the game show buzzers. We'll do lights. Okay. So you got contestant 1 over here, and he's got his button he's going to hit. And contestant 2, and he's going to hit his button, and they're racing. If you think you got the answer, you hit the button. Your light's going to come on when you hit your button, but when you hit your button, he can't turn his light on, or you can't tell whose light came on first. So as soon as you hit your button and your light comes on, you're also disabling his whole system. If he beats you to the punch and his light comes on first, in the same motion, he's disabling your chance to turn your light on. Okay? Maybe there's some way to solve this without a relay. I sure don't think there is. So let's just draw that in right off the bat.
Hey Dan,
yeah.
Is there an automatic reset? How does it reset?
That's a good point. So once everything's held, then there'd need to be the host has a button, and he's going to stop everything. Okay, so he's got his reset button. And I would say figure all of it at 24 volts, just so that you don't have an added layer of difficulty with these being 120 volt. Okay, so this is going to this whole setup, and when you're ready for the next question, the next round, you can hit this button, everything stops, all the lights are off, and everybody's ready to start again. Okay, I don't have 4 of these here, but you can still solve this. Maybe you'll just get as far as solving it on paper. I do have a couple lights that'll work with this, and you could probably just do it with the setups you have. But we've got 2 relays here, and there's only 4 across the tables. So once people have drawn it up and a few teams want to build it, we'll maybe do 2 stations like that. Okay, so let's draw in some contacts. If you want to use normally closed contact, just do that to your drawing. But I'm not going to tell you if these should be open or closed, and there's maybe a few different ways you can even do it. If you need a 3rd set of contacts, go ahead and add that.